Hi, my name is Kweku-Abeiku and I'll be presenting on improved disaster response system using drones. In Ghana, we have very poor emergency response time. With research, I found out that Ghana's national aim for emergency responses is 8 minutes, but we all know how that story goes. They never get there in any time 8 minutes. In real life situations, people have reported that these emergency services take a minimum of 45 minutes on a good day, and in the worst case, 8 to 10 hours. This is very scary and terrible, considering the fact that these are people's lives at risk. The rate of response of emergency systems could be caused by inadequate number of emergency vehicles. That means when an ambulance goes out, it has to come and restock before it can go out to the next victim or patient. The next one will be improper layout and naming system of streets. In Ghana, giving directions is a chore because following directions is actually a chore because you have people going around saying, "Oh, when you get to the end of the junction, you should see a blue kiosk. Take your right at that part." Or there's this plantain seller there. When you get to here, take your left and you will find the place. This is actually a very terrible way to give directions, and that doesn't help in the response time. The next one will be heavy traffic jams. Even as I speak, I'm sure there are people joining this meeting from cars and they are in serious traffic and they want to get to point B but they can't get there because of this heavy traffic. It's the same thing for the ambulance. When they are trying to get to the patient or the victim, it's very hard for them to maneuver their way to it. Even though they have sirens and everything, people still don't give them way. The next point to be bad and inaccessible roads. We can all testify to the fact that in Ghana we have terrible roads where they have potholes, and even at some points you can't even drive on them. So the ambulance would have to stop at one point and now have to carry their stuff to where the victim or patient is. My proposed solution would be a fully autonomous disaster response system using drones. One may ask, why drones? First of all, because they can be set to autopilot, so they don't need a pilot, unlike the ambulance that needs a driver every single time. The next one will be faster response time because the drone can fly in a straight line to where the victim or patient is. The next one will be the fact that the drone is less expensive. Comparing the two prices of the ambulance to the drone, we have an ambulance going for 320,191 Ghana cedis compared to a drone which should be 75,600 Ghana cedis. With the money used to buy an ambulance, you can get 4 drones operational on site. The last point will be the fact that they are very upgradable compared to the current response system, which is the ambulance. Getting new equipment to put in an ambulance takes a lot of work and time, and sometimes it takes over a month to install them. For drones, even though they have different manufacturers and everything, it's easy to get parts like cameras, lidar sensors, temperature sensors, and everything for it, and it's very upgradable. So now I'll talk about the implementation and architecture of the project. The first in the yellow section will be the initial proposed features I'll be using. I decided to use a USSD for the application, but we took that out and now we use a mobile application called Quick Response. The next one will be on the application layer. I decided to use DJI software and C# to program it, but that didn't go well. So I moved on to Pixhawk, Autopilot, HTML, JavaScript, CSS, and Python. For the database, I initially wanted to use SQL, but I had to move on and use Firebase, which provided a more stable platform to be used. So now I'll talk about the functional requirements and the non-functional requirements. First functional requirement I'll speak about is to locate the victim. The application should be able to locate the victim and send the person's coordinates to us. The next one will be to carry an acceptable payload. This payload will include the first aid or the aid requested by the user depending on the emergency type they specified. The next one would be to travel long distances. In case the victim isn't close to us or close to the ground station, it should be able to fly long distances to the victim. The next one is it should be fully autonomous. It doesn't need a pilot to fly at any given time. Unless maybe there's a failure or a failed check, then maybe a pilot can intervene. From the non-functional requirements, I'll talk about usability. Since this app will be used a lot in times of emergency and everything, it should be very easy to use and shouldn't have a lot of things to operate. The next one will be reliability and availability. Being an emergency app, there should be little to no downtime. The next one will be scalability. Since this is a proposed system that will be used for an increasing population, it should be able to be scalable at any time. The next one will be security. Since people's location will be sent to us, it's up to us to keep that data very safe. Okay, now so we'll move on to the demo. So what I have on the left is the mobile application, and what I have on the right is the web application. So right now, in case the person is on emergency, we have provided the field name, number, emergency type, and comment. Okay, so after all this, all the user needs to do is tap on request aid, and after the user taps on request aid, their information is sent to us. Okay, so now as we can scroll down to the end, we'll find out that my information has been sent. So Jaden, number, the location, broken ankle, and allergic to power. Yes. So as you can see, all this undefined data is when the user denies the permission when they install the first time they launch the app. If the permission of the location permission is denied, it would only send us undefined data. So it would be very important for the person to accept the permission. So this is a backend, the Firebase database that shows us the information request. Okay, so now as the data has been received, the person on the ground station has to input their name to extract the data from the website. So as the name was sent, Jaden. After typing the person's name, so it has to be what the person sent, it has to be the exact same thing. And for now, the program, so this program was written in Python, so the program will extract and scrape from the website using web scraping. It extracts it and creates the file we need. So right here, it has created the Jaden file with my number as the name. Now the next thing to do is launch Mission Planner. So Mission Planner is the ground station software that's used to autopilot the drone. So what will be done right now is to go into plan. This shows the ground station. So I set the ground station in UPSC, and right now we have to load the waypoint file which we created. So Jaden. So right now it has set a destination for my home here in Spintex. So right now all we need to do is write the data to the drone, and after writing the data to the drone, then the drone is ready to take off and deliver the package. So right now, since I can't show you the flying of the drone because I have no camera on board, I'll just show you a simulated route of the drone flying.